All right, good afternoon, everybody. Welcome back. So, we still have a minute yet, so I'm just getting on a little bit early to test out my audio here. But we shall begin in a minute. So, checking out my stuff. All right, audio, are you working all right? I always just look on my phone real quick through the stream just to see if I can hear myself. All right, good afternoon, everybody. All right, it's working. Okay. All right. Almost 2 o'clock on the nose. We'll begin right on time. And let's go ahead and get into it. All right. So, again, welcome back. It's Friday afternoon. I hope you all had a good week. We are heading now into a very nice long 3-day weekend, and I thought we could end off our work week here with a little bit of fun education, edutainment, if you will. Um, So we're going to pick up where we left off last time. So if you recall from our last stream, we had started to explore the Titanic data set. And so the Titanic data set, as a quick reminder, is a toy data set or an experimental data set that people use for learning about machine learning. And the reason we use it is because it's pretty easy to understand in the sense that it has to do with the Titanic that sunk 100 years ago or so. That of the same Titanic movie fame. So as or last time we had started to we imported our data set, we started to do a little bit of looking at things with pandas, and today we are going to start feature engineering. So as you might recall, machine learning is all very based on mathematical principles, and because math is numbers, we need to be able to convert our data attributes or data columns, data features into something that a machine learning algorithm can use. So with that, let's go ahead and jump in. So, oh, by the way, got my Polar Pop here today. In case you're curious, so obviously I go to Circle K just because it's up the road from my house, and they have Mountain Dew Zero, but they also currently have this little program right now they call Sip and Save, where if you spend $6 at one time, then for 30 days you can go get one drink a day for free, including one of these large guys here. So 6 divided by 30 works out to about 20 cents a day, which is super worth it because this is a great beverage, very refreshing. Probably not good for my kidneys. All right, so let me go ahead and share my screen. Okay. All right, so starting from sort of scratch. Also, I just recalled that I forgot to upload my stuff into GitHub, so I apologize for not having those notebooks. Let me go ahead and do that right now and just show you what Git does. I'm not going to cover Git today, but I'll go ahead and do a Git push. So cd into the Titanic SageMaker BYOC, git status. I always like to do is a git status to see what's going on here. So git add all, git commit m, uploading preliminary notebooks. Boom. All right, and then we do a git push origin master. All right. Rutro failed to push some refs. Oh, that's because I changed the name of the branch. Git push origin main. There we go. Okay, old habits die hard. So in case you're not aware, all these Git projects have decided to change the master branch nomenclature from master to main, and so I'm still used to kind of seeing the master nomenclature, but I'm getting used to switching it over, or I'm still getting used to switching it over to this new kind. So just be mindful. So if you do have existing repositories out on GitHub from a couple months ago, they may still have the master branch as the primary branch. Just note that if you do create a new branch from GitHub, it will default to the main branch. All right, so now it should be up in GitHub. Let's go ahead and check Safari here. No, I accidentally locked my computer. I hope. Are you still there? Okay, I didn't lose the stream, did I? Okay, I really hope I didn't lose the stream. So I use this little keyboard here, and up right above the delete key, I don't know if you can see that, is a lock key. And so if I accidentally press that, it accidentally locks my computer. So sorry about that. All right, so what was I doing? Safari. And I accidentally, I don't know why they put that so close to the delete key, because I use the delete key so often. All right, so we'll go into GitHub here, and then we shall go into our repositories, and then the Titanic SageMaker BYOC, and there we go. There's our stuff. Our notebooks uploaded 2 minutes ago, which is about accurate. All right, so like I said, I already have my Jupyter server up and running just because I already have that running in the background on my computer at all times. So if I go to localhost 8088, then there we go. There is my repository. So we'll go in here, we'll go in here, and we'll start with it. We'll do this feature engineering notebook. All right, so let me go ahead and clear out I like to start with a fresh kernel. Okay, so you see a little bit of work in here. Everything we did in here so far is just kind of like a cleaned up version of last time. Obviously, you don't see all the other stuff that's like showing like the actual data set itself. So just 1 second, because I'm looking at my little thing right here and it's spinning. So I'm wondering if my stream did get screwed up when I accidentally left my computer. So let me check this real quick. Sorry about this. Still working out technical kinks. I think I'm fine, but I just want to make sure, for sure. Okay, all right, I can still see me on here, so hopefully you can too. All right, so like I was saying, so the only thing that I was doing in here is just, importing the libraries that we need, importing our data set, and then, so whenever what we did last time as far as feature engineering goes, we dropped to the columns that we don't need. So we determined that passenger ID, name, ticket, and cabin were not required. Excuse me, and then we changed the sex or gender column from the male and female values to numerical values representing those. So, excuse me, 0 for male, 1 for female. And then we changed that type to int, and then we separated the data set between the x and y. So if you remember, the survived column here is our predictor value, and so we separated it out into y. So now we can start with our feature engineering, but let's go ahead, since it's been a couple days, let's go ahead and look at the data set again. All right, so x.head. So again, reminder, head is going to look at the first 5 rows of our data frame here. All right, so you can see we have P class, sex or gender, which has already been changed into a numerical value. Age, SIB, SP, so that's the number of siblings that the person supposedly had on the ship. Parch, which stands for parent or child, and that determines how many children or parents were with you aboard the ship. Fare, and now that I think about it, I'm wondering if fare, like we can even do anything with fare, so we'll come back to that one. And then embarked. So embarked is, let me go ahead and pull up the data dictionary. So Kaggle Titanic. All right, so come on, load up. All right, so let's go into our data here, and it should show the data dictionary when we expand this. Okay, so embarked is just the where the I guess the Titanic embarked from multiple ports. I don't know. I'm not super well up on my Titanic history, obviously. And now that I think about it, I don't know if I've ever seen Titanic all the way through. Titanic came out when I was a kid, and I've not really had like a huge reason to want to go back and watch it. But anyway, so C stands for Cherbourg, Q for Queenstown, S for Southampton. Okay, so back to our notebook here. So we need to do some feature engineering now to appropriately craft these the current features into more appropriate numerical values. And so some of them are already in numerical values, but we're going to be doing some adjustment to those anyway, and we'll explain that more in a little bit. And we also have to cope with the nulls. So if you recall, here, let me just show you x.info. So x.info, as a reminder, it just shows you like what you have as far as your data set goes. So you can see that the data types of each of these values, and then how many non-nulls there are. So there's a total of 891 records in this data set, but you can see that some of them are not quite populated excuse me, all the way through. So you can see that embarked has 2 values missing, which is pretty minimal, fortunately. And then age is another one. Age has 714, so there's 100 or so missing there. If you recall from the previous time, we already dropped cabin, but cabin only had like 200 populated out of the 900, and we determined that if you have way more nulls than you do like have values that for that data, it's probably not worth using that feature. So that's why we just dropped it entirely. And so again, there really is no like set way to create a predictive model. In the sense of like what features you should select versus what features you shouldn't select, which algorithms we should select, and we'll talk about algorithms probably next time. But yeah, so these are the ones that I've selected, and then I'm going to engineer them even further. One thing that I should mention about data science in the real world, as opposed to like this toy data set, is they're handing us like this data set on a silver platter saying, here you go, here's the data that we have, here are all the, what was it, like 14 or so features and the predictor value. Data obviously is not going to come that clean, nor like, or is it going to come like on a silver platter like that. In the real world, you have to basically work with what you're given, or what you have, I should say, and try to figure out like what you want to do with the data. So like in this case, it's pretty simple that we want to create a predictive algorithm that would predict who would have or who would not have survived on the Titanic. But in the real world, if you were trying to create a predictive model around I don't know, customer churn or something like that, you're going to have wildly different features. So I would imagine a company like Google, who is very big and has a lot of data, can do a lot more than like a mom and pop shop that just, is purposefully not gathering that much data. And so again, let me also say this, data, this is an interesting one. I would encourage what we call ethical AI. And so what ethical AI is basically, so we're using data here to make generalizations, of course, to find out who lived and who died aboard the Titanic. And there are some pretty strong ethical implications for real world usage here. And that is, you could create a predictive model that is, because it's looking for patterns. And if you think about patterns and whatnot, demographics of people are also patterns. So let's say I wanted to create a predictive model around the best candidate for a CEO. If I were to use historical data about CEOs in the past 100 years, it would most likely point to like an older Caucasian male. And that's just because that's what history was. But that doesn't mean that if you create a predictive model around somebody of a different demographic, if that be an African American person or a woman or somebody who's gay or trans or any of those things, the model would say that you should probably select a white person or a white male, and I would disagree with that, and I bet you would as well. So ethical AI is making sure that you use your features appropriately and don't do any kludgy business like that. So yeah, so that's just a little bit about ethical AI. I'm a huge proponent of it, of course, because we want to be fair to the rest of the world. So, and the same goes with just data collection in general. Obviously, you don't want to collect more data than you really need to, and that's a tricky fine line on what that is. And I'm not going to delve into that right now because we're starting to get off topic. So let's get back on topic with feature engineering. Okay, so where were we leaving off? So we looked at the first couple rows of data here. Oh, so fair. So we did not look at fair last time. I don't know if fair is going to be a great predictor value. So let's go ahead and do a little just looking at what fair is. So one of the first things that I like to do, as you might recall, is I like to look at the value counts. And I don't know if value counts is going to be really good here because there may be wildly inconsistent categories between the values. Okay, this is interesting. So you can see that 43 people bought a ticket around $8.05, 42 people around $13, and it looks like there's a lot of other values. So you can see length here. Length is basically saying there's 248 different prices that people paid for these tickets, and I wonder if I can. So I tried to do a hist last time, a histogram. I wonder if it'll work on this one. I really hope it will. Okay, I don't know what I'm doing wrong. I don't know if it's me that's doing something wrong, or if, like I said, so right now I'm working off of a Mac Mini that I just got 2 weeks ago, and I've still not fully installed everything, so maybe I just haven't installed something properly. So I apologize for that. But I don't know. You know what? I think I am going to keep fair in there just because it is a numerical value. It's already float, and maybe it could be predictor. And so again, you may or may not make the same decision as me, and that's totally fine. Um, Obviously, this is just a toy data set, so no stakes or anything here. But so if you want to keep fair in, go for it. If you don't, then you can take it out. I'm going to keep it in just because. All right, so that leaves our other features. So let's talk about the remaining features here. So we already did deal with sex or gender here, and so we're not going to touch that any further. P class, I think I'm not going to adjust either, just because it already is in numerical form, and I think there's only 3 classes. In fact, let me check that real quick. So X P class dot value counts. Yeah, so I was right. So there's only 3 different classes here, and they're pretty. I don't want to say evenly distributed, but like it's not like everybody's in 1 or everybody's in 3. So there's a little bit of a variance in there, and this is probably going to be valuable for what we know. In fact, I want to go back and look here just to see. Okay, so first is a first class ticket. So I'm assuming 1. Like first class ticket means that it's the nicer ticket, I guess you'd say, which would make sense. Well, actually, it is interesting that there are more first class tickets than there are second class tickets. Yeah, but in any case, I'm not going to adjust this feature at all. I think it's good to go as is. We are going to do something with age. We're actually going to do a lot with age, but we'll come back to that one because that one's probably going to be the most. That we're going to be doing to any of these features. SIB, SP, I think this one's good to go as well. Let me just do a quick check. Okay, so yeah, not much here. So interesting that there were 8 or 7 people that had 8 siblings aboard. Wow, that was must have been a family or something. All right, so let's do Parch as well. I think this one's going to be good to go. Okay, yeah. All right, one person had, okay, I was going to say one person had 6 parents, but I forgot Parch also stands for parents and children, so I guess you could have had 6 children, which I guess would have made sense with the SIB SP from before. Fair, we already talked about, and then embarked. So let's do the feature engineering on embarked. So let me, just for organization's sake, so engineering the embarked column. All right, so again, reminder that is marked down. These little pound signs or hashtag signs will give you different levels of headers. So if you wanted a, like this is a first level header, second level, third, and I think you can go up to 5. Yeah, and then it just goes blank. All right, so I like to do 2. I like to reserve 1 for the very top one, and then 2 for the following ones, and then maybe 3 every once in a while. Okay, so, all right, so where are we at? All right, embarked. All right, let me do checking the value count on the embarked column. Also, so just FYI, if you have any questions along the way, I am monitoring the chat down here. I don't see that there's any questions, and I purposefully do not know how many people are watching. It could be 0, it could be 5 of you. I don't do that because I get nervous, if I'm just being honest. So, all right, so checking out the, all right, so X, all right, embarked dot value counts. Okay, so you can see that we have, all right, so there's not, I was wondering if it would show the null values, but apparently it doesn't. Because as you might recall from above here, there are 2 null values. So one of the very first things that we need to do when doing our feature engineering is decide how we want to handle nulls. And there are several different ways in which to handle nulls. And so we're going to explore one option here with embarked, and then we're going to explore a totally different option with the age column. And so with the embarked column, the question is like, you want to be fair to the data. You just don't want to go making stuff up. But you also want to select like what is the appropriate path forward. So in my personal opinion with this one, so you see that we have 644 people that embarked from S. I'm just going to call them by their letters just because I can't remember what the names. I know they're in here, but it is what it is within the data. So we have 644 with an S, 168 from C, and Q has 77. So what is the best way to handle this particular feature? So a little bit of a spoiler alert with age. Age, you'll notice, has a lot of missing values as well. I think, I'm trying to remember because I've done different things with age. I think age, I end up going with the median age, or maybe the mean age. I don't know, the average age, of course, but there's different kinds of averages, mean, median, mode. Mode's not going to really be super helpful here since there's float integers in there. I think I'm going to go with median there. But in this case, with the embarked column, I personally think it makes sense just to go with the average in the form of mode. So in that case, that would be S, just because there is an overwhelming number of people coming from that S port. So with these null values, I am just going to do a straight fill with that S value. So I'm trying to remember how to. So again, this is one of these things where it's better to conceptually understand what you need to do than memorize the syntax of how to actually do it within something like pandas. So the reason I say that is because I cannot remember off the top of my head how to fill nulls, and that's fine. We'll just Google it. Google, all right, google.com, pandas fill nulls. Okay, so fill NA, so this is right. And so, by the way, as a reminder, I am a machine learning engineer and not necessarily a data scientist. There is a distinction between the two. I would say the data scientist role more so focuses on building models, which is what we're kind of doing here. And so with feature engineering, and then a machine learning engineer is more of a software developer and helps to take that model, package it up, and then be able to push it out into production. So you'll notice whenever we get down the road of actually like our model is ready for like a deployment kind of status, that I'll be much more quicker about that stuff because that's what I do on a day-to-day basis. This sort of work I don't do on a day-to-day basis, and that's why I don't have it memorized. But the other stuff I can really fly through. Okay. So, I am kind of glad that we looked at this though, because with this documentation, you can see that there are different parameters or what you might call options of what you can do with this null. So NA was standing for null. I don't know if it actually stands for something, maybe not applicable. But anyway, so Pandas data frame, we're filling the nulls. So the first parameter here is the value that we want to, or the feature that we want to fill for in this case. So in this case, we are the value is going to be our embarked column. And so it's interesting here that method. I wanted to bring up method here because there are different things that you can do with this method that I totally forgot about until right now. I'm just looking at this. So you notice that you can see that there are different string values called backfill, bfill, pad, and ffill. I don't remember exactly what these do, but what I do know in general is I think that if you select one of these methods, like let's say I think bfill or forward fill, it will just grab the value from the previous record and then just fill it that way, or from the next record and then fill it that way, which we're not going to do. We're going to be very specific about how we're going to do this. And so again, I mentioned before that we have the in-place value here. And yeah, so I probably will not get this right the first time, and that's okay. That's the one nice thing about software development is, as opposed to like building a building or hardware or something, is if you screw it up, you just hit the delete button and we try again. So, so let's see how this goes. All right, so X embarked dot fill NA, fill NA with, let me go back to our documentation here. I think, so use values to fill holes, alternatively use dictionary. So I wonder if I can do, so I'm not going to do in place just because I want to see if this is going to work. So I mentioned we're going to fill it with S, And so, okay, so I think that worked. So let me try the in place equals true. All right, well, and again, just for um, your sake later, I did a pretty bad job of like keeping this organized last time, so I'm going to try keeping this organized better this time. So I'm going to put, again, if you're not doing Markdown, if you're just doing straight Python code, the pound sign, one single pound sign will add a comment to your code, which I like to do because with all my code, regardless of it Python or if it's Terraform or whatever, I like to put comments on here because it helps to explain the code better. And even just for my own sake, so we're here on a Friday. If I was coding this on a Friday, 3-day weekend, have a lot of fun, forgetting stuff, coming back, and I can read the comments and understand what the code's doing a lot easier than just reading the code itself. Okay, so let's fill nulls. We'll fill embarked. And I like to use I don't know what you call it, is it present participle verbiage? I don't know. The one that ends in ing. Filling nulls with, or embarked nulls, I should say. Embarked nulls with the letter S. Since S is the mode. Yeah. Okay, so sorry, I was just thinking about something there, and I lost my train of thought. So we're filling the embarked. Oh, that's what I was going to mention. So you'll notice I'm doing a lot of things in single quotes. Most programming language, it doesn't matter if you use single quotes or like double quotes. In fact, more people use double quotes. I personally prefer single quotes just because I think it looks cleaner, but it doesn't really matter. Like if you wanted to do double quotes here, that is fine. There are a couple. I'm thinking of Terraform specifically, and we'll talk about Terraform way down the road. But Terraform, you do have to in certain cases you do have to have that like double quote versus single quote. Anyway, all right. So fill on A, and then with the letter S. In fact, so with one thing I should also mention. So coming back here. So you can see that these are the parameters that it expects, and then you can see that so it is expecting value, method, access, all these. By default, so like what it says here, value equals none, that is the default value that it'll put in. And so if you don't fill out one of these things, then it will by default select one for you. Or actually, well, so I misspoke a little bit, sorry. It will show you the default value down below. So you can see here that the default value for method is none, default value for in place is false. And so you can theoretically just, if you want to select your options for each of these things, you can just put them in order without necessarily specifying value equals, method equals. And so most of the time you'll see in coding that the very first value or option or parameter, which is usually the most important one, people just generally don't fill out what that means. So you even notice probably in here, that when I did the pandas read CSV, it's not like I put like what the parameter name is. But you can see down in here, like I do put the in place. And that's just because if I don't put that in place, I don't know what the second parameter it's expecting is. In this case, in place is 1, 2, 3, 4, the fourth parameter. And so that's why I specify it. So just to, well, you know what? I'm not going to, because I was going to put the value here. And I want you to get used to seeing what the real world will be like. In the real world, most people aren't going to put that. But they will put in place equals true. And so also, again, I like to put spaces in between things. I think you can put as many spaces as you want, and it's still going to work. I personally just like to put one space in between things just because I think it cleans things up. Do note, so that works just fine for Python, but for like operating on the command line, spaces can screw things up, so don't do that in the command line interface, especially like when you're exporting values or whatever. All right, so I'm going to run that. All right, and I just want to do a quick check again. X dot info. So if this worked just fine, so you can see the 889 non-nulls from above here. When I hit this enter button again, we should see that those null values have jumped up to 0 basically, or 891. So there we go. Everything is full. Oh, I forgot. Duh. All right, so we do need to engineer this feature a little bit further. So what reminded me here is you can see that the data type is noted as object, and most of the time when you see that object data type, that usually means it's a string. And so a string is just like a set of characters or a set of like letters basically. And so obviously these are string values here. They're just single character string values. So we have S, C, and Q, but we need to transform these into numerical values. And so in this case, we need to do something called one-hot encoding. And the reason that we do this is because above we were able to with the gender column we were able to skate by with just doing a straight like numerical encoding just because there were two values. There's a 0 and 1. If I were to try to do something arbitrary like that for here down below S, C, and Q, doing a 0, 1, 2 or a 1, 2, 3, that is a misrepresentation of the data because it's kind of implying that there are more than it's implying like a almost a hierarchy. It's so let's say I gave S1, C2, and then Q3. It's almost implying, or like with the mathematical values behind the scene, that Q is more in value because it has the 3 in front of it. And we don't want to do that because that's not true. So the way we handle that is we do something called one-hot encoding. And so what one-hot encoding is, and in fact, I actually have a better notebook that explains this one. Let's jump into that notebook, and then we'll come back here and apply the same principle. So I'm glad I remember this because I actually just looked at this yesterday and I thought, oh, this is nice. All right, so this is part of another blog post I did a couple months ago called 2 Ways to One-Hot Encode. So what I did here was I created a little data frame that had just a couple values in it. So you can see this is the animal feature. And so we have as part of our records cat, dog, bird, monkey, elephant, cat, bird. So you can see we have a couple of repeats in here. And so what one-hot encoding is going to do is it's going to transform these values into each of their own respective features. And then so like the bird feature will have it will surface a 1 if it is a bird, and then a 0 for everything else. So this is one way you can do one-hot encoding. So this is, and you'll notice this is what I call the incorrect way. This works just for demonstration purposes, but I'll explain why you shouldn't do it this way here in a second. But so you could see we have 5 different values in as far as these things go here. And so using this pandas get dummies feature, it is extracting out those values into their own feature. So you can see with the bird feature, record 2, which is bird, has a 1. Record 6, also bird, has a 1. All the other ones are zeros. Cat, same thing. So record 0 has a 1. Dog, elephant, so on. You can see so this is what we call one-hot encoding. So Pandas does have this feature called get dummies that does this for you. The reason that we don't use get dummies is because there's not a way to correctly guess on new values going forward. So let's say that we added a 7th value or we create a predictive model and we fed it a record with the animal value of chicken. Chicken is obviously not a part of this, so how do you handle that? With the get dummies feature, there's not really a way to handle that cleanly. So you could try to hard code something that will do like another thing, but that is not clean and is very messy and is not preferred. So what we do instead is we use one-hot encoder objects. So one-hot encoder objects here, my cursor's messing up. One-hot encoder objects are going to handle these values appropriately, and then if it can't, if we don't have like let's say if we try to pass in a chicken, it will know necessarily how to deal with that appropriately. So there are 2 ways to one-hot encode using different Python libraries. One of the more popular Python libraries, and we'll be exploring it more in maybe later on the stream and in other streams, is holy wow! I can't believe it's already been half an hour. Is scikit-learn. So you can see at the top here, I imported. It's often shortened to just sklearn. And well, you can see that it's even called the library that. But there's also a library called category encoders that some of my fellow data scientists showed me within my role. And I actually like category encoders better just because I think it's a little bit cleaner. And we'll see why here. So you could see, well, so let's talk about what this is doing and then we'll apply it here. So what we do here is first we instantiate like a scikit-learn one-hot encoder object. And so we do that by getting it from the library here. And so I've set it here as sklearn OHE. And then we can perform different functions on this one-hot encoder. So we're going to see this moving forward with our predicted models, is we fit the data to the like the object. So in this case, and then later on, if you want to appropriately do what you need to do with the data, then you do a transform. Now, and if you want to do both at the same time, you do a fit transform like we're doing here. So what I did here is I took my animals data frame here. We did a fit transform on our sklearn one-hot encoder to get our sklearn dummies. And by default, you can see that the output of the sklearn dummies is this what they call a sparse matrix of this other library that called NumPy. And NumPy is a really important Python library that helps out with other things, but I'm not going to cover that right now. And that's why I don't really like this, because by default, it just goes into the sparse matrix. And if you want to transform it back into a pandas data frame, you have to do a little bit more. And so this is what I'm referring to here. So I actually have to get the categorical names here. So you can see that by getting our one-hot encoder object, doing a dot categories, you can see our categorical names here. And then so down here we are basically reinstantiating the pandas data frame by getting the data to array and then getting the columns here, and then it does fill all these things back in here. But you can see that it transformed them into float values, which I don't know why it does that, because these were obviously integer values before. So that's why those are the two reasons why I'm not wild about the scikit-learn encoder. Is it first does that sparse matrix thing, and then you have to transform it later, and then also it does the weird float value thing. So my preferred form that my data scientist once showed me within State Farm is that there's a different library called categorical encoders that does something very similar, but it cleans it up a lot more easily. And it does, so you can see here, so we're instantiating the object once again. So we are instantiating our one-hot encoder using the categorical names, and then doing a fit transform again on the data. And you could see directly, we didn't even have to do this business of having to reinstantiate our pandas data frame. You can see that we have a data frame here that has our values already good to go. And not only that, but it does this, what I actually kind of like is it kind of shows the origin of the feature. So if you remember the feature, the original feature's name was animal. So instead up here with the scikit-learn, it just took the value name and called it the feature, the feature, the name of that value. But this one actually does a little bit of extra appending where you can do like show like the name and then it shows the value. So you can kind of see the origin where this feature kind of originated from, which I think is nice. And so it's just a lot cleaner. And so you can see that I did that in 2 lines of code here, just basically this code, this line and this line, and we got, and it's got integer values, whereas the scikit-learn version is a little bit longer. Both versions work just fine, don't get me wrong, and there's more than one way to do things within data science and community. I thought I'd just point this one out because this one is not as popular, or let me rephrase, it's not as well known, but I personally think it's a lot more convenient. And we'll talk about what this job-lib thing is doing down here. So I don't even know if I have category encoders installed in my machine. So I guess that's a good this is a good learning thing. So if you want to install a new package that you're not familiar with, the best thing you can do is go and find the documentation about that package. So the package name is categorical encoders. It might just be category encoders now that I think about it. Yeah, it probably is just category encoders because it's just showing me scikit-learn category encoders. Okay, so there's PyPy. All right, so this isn't exactly where I want to go, but I'll go ahead and show this as well. So this is a PyPy page. So PyPy stands for Python Package Home. I can't remember what the I stands for now. Inventory, maybe, something like that. But basically, kind of like I mentioned before with these Python libraries, they're kind of like additional features that you can add on to Python. PyPy is where developers upload, or maybe not necessarily upload, but make available different things that people can install using what we call pip. So pip stands for, I think it's just like I don't remember what pip stands for, honestly. It's the way we install our Python libraries, though. So you can see here that if I want to install category encoders 2.2.2, then we just click this little guy here, and that's going to copy this to our clipboard, and then we can go and install this. But I didn't want to come here necessarily, but maybe this is actually an official part of scikit-learn now, and that's why the documentation wasn't showing properly. But anyway, if you want to see the documentation from PyPy, then you go to Project Link's homepage, and okay, so this one just took me to GitHub. Sometimes it'll take you to like the actual special website. So let me show you scikit-learn, because I know scikit-learn is very robust with their documentation. So scikit-learn, so this is the home page for the scikit-learn package, and so this is what I kind of want to show, because I thought category encoders had something similar to this. Usually, one of the these more mainstream kind of websites will have like their own installation instructions. So you can see here, like if you have Windows or Linux or Mac OS, or if you want to do a pip install this way, or if you want to do a conda install, and I'm not going to talk about conda right now, then you can do it this way. But apparently category encoders just has a GitHub page, which is fine. Category encoders isn't necessarily like a huge package, meaning that like it may not merit like a fancy documentation website like scikit-learn has. Scikit-learn is just such a big library that's why they have their own fancy package. So getting parched. Let me take a sip. All right. And I'm just doing a quick check to make sure the stream is working okay. Okie dokie. So let's come back into our library here. Okay, so to actually do the category encoders installation, so wait, I already installed it to my clipboard, or copied it to my clipboard. My nose is just super itchy right now. Sorry about that, folks. All right, so I'm doing the install. That was pretty quick, and so you can see that installed category encoders 2.2.2. Another quick thing, and we'll get to this more later. I don't want to delve into this right now, but versioning does matter. So you can see that we're using 2.2.2 here. For our purposes, it's okay to use just the latest versions, but we'll talk about why you want to pin your versions, meaning that you can set it to where whenever we actually create a package around this model that will deploy out into a production environment, we want to make sure it is using very specific versions of packages. And we'll talk about that more later. I feel like I've already done way too many deviations, and I can't believe it's already 2:42. So I don't even know if we're going to get through all of our feature engineering today. But some of this is a walk down memory lane, because I haven't done anything with category encoders in a while. All right, so in order to use category encoders, I am going to grab this line of code here, because this is just importing the library that we need, and come back into our other notebook. And I like to put everything like together. So like I could put this import here, like way down here, but I like to put like all my imported stuff from up here, and I'll just run this cell again. So as you can see by the numbers on the respective side here, that this is telling you the order in which things have run. If you want to, there may be reasons why you want to restart everything. So I didn't mention this before. If you do want to restart what they call your kernel, then you go to your kernel, and then you can do a couple different options here. You could either just do a restart, or a restart and clear all output, restart and run all. You can change kernels. So I only have the Python 3 kernel in here. If you ever do use SageMaker, AWS SageMaker, which we will talk about at some point in the future, AWS SageMaker has like like 15 kernels by default. I just have the one, and that's fine. So I'm going to do a restart and clear all output, and so this is going to clear out everything that we've done to date so far, so we can just do a quick run of all these things. All right. Excuse me again, and let me come back here. So again, I don't remember exactly how. I'm trying to remember because I mentioned before that like if you had like the chicken value that I would know what to do here, and I think I don't remember exactly how that works because I didn't do it here, obviously. So again, we're gonna have to visit our friend Google here. So Google, please help us out. All right, so Google category encoders, one hot encoding. There we go. All right, so category encoders. So maybe this is a part of scikit-learn now. Okay, so here's our documentation. Handle. Okay, so you can see here we have a handle unknown. All right, so we are going. So the nice thing about this is if you don't know how to fill it, then you can fill it with an appropriate value. So actually, so I made a bit of a mistake, and that's okay. Like I said, mistakes. We can. Go back and do stuff. So I actually did a fill NA here, and I would say that was not necessarily appropriate because I actually want to do a fill NA whenever we're doing it as part of this categorical encoders kind of thing. All right, so that means I need to restart. I'm going to delete this cell out. So the way we delete our cell, I don't remember if there's a clean way to delete cells. So I always just go, let me zoom out a little bit. I select the cell and then I just cut it. I kind of like the Juno Connect interface better if you remember from my iPad because it actually does have the little trash can icon that you just boop, tap and it's gone. Excuse me. All right, so let's do a restart of our kernel because we already messed with that embarked column and I don't want to, I didn't mean to do that necessarily. Okay, so embark.value counts. All right, so first things first, we need to instantiate our object, our one hot encoding object. So instantiating the one hot encoder object. One hot encoder is often abbreviated to OHE, just for your awareness. So I'm going to call this embarked OHE encoder. And I know that's a bit redundant because OHE is basically I'm saying one hot encoder, but yeah, it's easier for me to remember this way, and it probably is for you as well. So one hot encoder is got to go back to my other notebook, trying to remember how I did that. One hot encoder. Use cat names. Wait, is that right? Let me go back. I apologize. I can't really remember off the top. Okay, one hot. Hot.one. Oh my gosh, I should just copy and paste this. All right, one hot encoder. Live typing is not fun, folks. You make a lot of mistakes. I feel like I'm getting better with these streams, though. At least the lighting looks better. Oh, by the way, in case you were wondering, you might have noticed that I'm at a little bit of a different angle today, and that is because for my birthday, I got a new desk. It's just from IKEA, so nothing fancy, but it's just a lot more conducive to my setup because I did have my webcam just sitting on top of my water bottle, and now I have a dedicated little shelf for my webcam, so that's so nice. All right, sip of my drink. All right, so we need to alter the parameters appropriately, so I think I want to all right, so options are error, return NaN value, the default is value, warning if an extra indicator is used. Okay, I wonder if what the difference between handle unknown and handle missing is. I don't know, I don't remember. That's okay, we'll learn together. All right, so I do want to use the cat name, so use cat names equals true, and then we'll just see how this works, and if it doesn't work, we'll just try something else. So handle unknown, or okay, let's read this. All right, All right, if it has NaN values. I wonder what the difference between an unknown value and a NaN value is. I think this one sounds more appropriate because these are NaN values, so we'll do handle missing. So handle missing equals S, right? Right. Okay. I am very curious to find out like if this is going to work all right. And so the way we're going to do that is we're going to check to see what the current NaN value is, or which record has the NaN value, and then we'll go back after we fit this data and see if the NaN is has been appropriately handled with the letter S. Okay. So I'm trying to remember how to do this. All right. So X embarked. Dot. Okay, I think it is the way you do that is X embarked equals or no dot is null. Okay, I think that's right. Okay, so there we go. So you can see that record number 600 or 61 and record 821 are the NaN values. So let me put a comment here. Showing which records from the raw data set are null. Which embarked records, I should say. Embarked. Oh my gosh, I can't type. All right, there we go. All right, so the NaN value's there. All right, so let's see if this works. So I'm going to come back and reference my thing here again. All right, so, all right, embark. All right, encoding or performing one hot encoding on the embarked column. Oops, sorry. Column. All right, so, all right, why am I struggling today to remember some of this stuff? Okay, so we are going to fit transform our. We don't want to fit transform the whole data frame. We just want the one object. All right, so embarked. I'm going to call this embarked dummies equals. I don't want to go back. I'm going to see if I can remember this. Embarked one hot code. By the way, so one nice thing about the Jupyter interface is if you start to type something and then you do a tab over, and then it'll it'll autofill, and if it's not sure what to autofill with, then I'll give you these options. So I want the one hot encoder dot fit transform, and so we need the X embarked. Boom. All right, so let's check this out. Viewing the embarked dummies. Embarked dummies.head. Okay. Oh no. Okay, so it did not seem to handle that correctly, because if you recall right, then we wanted to handle nulls with filling it as the letter S. So I want to see what it did, but just to let's look at the X embarked data frame as it is. So as you can recall, I'm not actually altering the original X data frame at all. I saved this embarked dummies as its own thing, so I can go back and view like the head here. All right, so letter S. Embarked S 1, and the other ones are zeros. Correct. C 1. Correct. 111 for all these S's. So lots of S's at the beginning. Let's see if we can find some more values from the tail, maybe. Okay. And tails. All right, so SSS 111, C, and Q. All right, cool. But we do have a NaN column here. So if I want to look at what that is, so embarked dummies. So let's .iloc. So iloc stands for like index location. So I know that my index location is, I think this is the right way to do it. So I might screw this up as well. So iloc 61. Okay, so this is correct. All right, so at location 61, you can see that it did fill in the NaN value as such, which is not, so it did do what it intended to do, but it didn't do what I wanted it to do because I think I did something wrong. So again, so let's try, so going back to our, I think here, let me close out some of these tabs because I get confused I get too many tabs. I know people that have like literally like 50 tabs, and it's just like, oh my gosh, yeah, how do you do any work? Uh, I try to keep no more than 4 tabs open. Um, okay, so let's do handle unknown instead of handle missing and see if that changes anything. Handle unknown. Okay, so I'm gonna, oops, handle unknown equals S. All right, so okay, fitting there. Okay. Okay, well, that didn't work either. Okay. Huh. All right, well, I am apparently not remembering how to handle this. Um, Options are return nan error value, default is value, if indicator. All right, so sometimes they do have, if you look in this documentation, it'll show like examples of how things are done, so you can see, or it'll show other things. So, oh, I didn't even know this had a reverse dummies. That's interesting. So you can see the fit transform, get feature names, get dummies, but that is not what I wanted it to do with the nulls here. But maybe that's okay because, like I said, coming back to our chicken example, like let's say that they had another embarking point of I don't know, New York City. And for some reason we fed in New York City. We do want it to show up as something that is not what we would expect it to show up as. So I wonder if we handled, if it is okay that we actually do create a feature like this that does handle those unknowns. So basically, whenever if we were to fit the data, some new data point to the model, and it had like a New York City attached to it, then it would just drop into this nan column, or we'll call it the other column. So I wonder. Let's see like how we can handle that instead. So, all right, so return nan indicator. I'm just very curious what error does. So let's try this out. So error, error. Okay. Okay, it didn't seem to have done anything. Okay, well, let's try some other things out. Return nan indicator. I'm going to try out indicator because I don't know what indicator does either. So this is one of these things where, well, let me come back to here just to show you what I'm doing. So it says here options are error, return nan value, and I'm assuming value means warning. If an indicator is used, an extra column will be added in if the transform matrix has unknown values. Okay. Oh, okay. So I don't want to do that. I want to do this instead. Warning, if an indicator is used, okay, well, I'm confused. Handle missing, handle unknown. Again, I'm not a data scientist. I'm a machine learning engineer. So, but this is good. This is good practice for me as well because I do want to grow my data science skills. And if anybody's watching and has any tips for me, please feel free to put them in the chat here because I'm a little bit lost right now on what to do. All right, so I did want to do indicator because I don't know what indicator meant. Indicator. Oh, okay. That added this weird extra column with the -1. So now I'm curious what this looks like. I have no idea what that does. Okay. Well, let's just come back to here and then handle unknown, or I can't remember if it's handle unknown or handle missing. Handle missing. Let's see what that does. Okay, so that just created a nan column again. So indicator. Wonder what return nan does. Okay, let's try this. Return nan. Ruh-roh. We didn't like that. That did some weird stuff there, as you can see. All right, I didn't want to do that. All right, so let's just do handle missing. Well, I want to try one more. Well, none of those we tried them all. Okay, so let's just do the letter S again. Except I'm not confident that it's going to really do anything for me here, or what I want it to do. Okay, so I'm trying to think because it's good to have this for training purposes. Well, you know what? I am going to keep this in here. I don't know if this is the right way. I'm going to look later at another time because we're already almost at an hour, and I don't want to spend too much time on this one darn feature. So we'll just keep this as is. So one thing you will note is that embarked dummies is its own data frame, and it is not part of the X data set. So what we want to do is we want to join these features back in, and then we want to get rid of the original feature just because we don't need the original feature anymore. So just as I always like to remind myself, all right, what is actually in head right now? So we have their embarked. All right, so the way that we join these guys together is we do, all right, so joining embarked dummies back into X dataset. So we do a pd.concat, and so the first value that we want to do is I think this is the way you do it. So you do X, then embarked dummies, and then axis equals 1, I think. And so just noting what axis is, there's 0 or 1. 0, I think, indicates a join on the rows, which we don't want to do, and 1 does a join on the columns, which is what we do want to do. So I think this is the correct nomenclature. Okay, so that did work, but you'll notice that this isn't, like, I just did a straight pd.concat. I didn't actually concat it back into the X data frame, and so just to prove that, let's just do a quick x.head again. So you can see that it's back, because we didn't manipulate the object itself. So if I wanted to go back and actually change that object itself, then I would just do x equals pd.concat, and then we go back and look at it again, and then it's all there. All right, so we have attached our new one hot encoded columns. We do need to get rid of the original column, so we'll call that getting rid of original embarked column. Oops. All right, and so this is going to be what we did before, and that is a x.drop columns equals embarked, and then in place equals true. And so you can see it's pretty obvious when you to tell like which ones I do have memorized and which ones I don't. So read CSV, I do have memorized because I do that one all the time. I also have dropping columns pretty well memorized. I surprisingly had PD concat memorized. I don't know why. And then the other things like header tail. But then there's these other things like one hot encoder that I don't have memorized. And again, it's more important to understand the conceptual idea of what you want to do, because then you could Google later what you need, like how to actually do that. So in my mind, it's far more important conceptual understanding than memorization itself. All right, so we handled one feature in this 1 hour, and so I'm tempted. I don't know how much further I want to go. Well, all right, let me check real quick. So, all right, so these are features. Why did it show X? Why did it not drop him? Did I not run this guy? Did I not run it? Embarked? Oh, because it's got a capital E. Capitalization is important, folks, so I messed that one up, so no big deal. All right, so if I do an X, then, okay, it is gone now. All right, so I mentioned we're not going to touch any of these. So the other big one remaining is age. And yeah, let's go ahead and do it. I got time. You got time. Or if you don't have time, you could leave, come back. This stream will be available for replay later. So let's go ahead and do the age column, because this one's going to be, we're going to do two things here. So the first thing that we need to do is we need to handle nulls. And I kind of alluded earlier that we're going to do a little bit different thing with handling nulls here. All right, so what did I call this? Engineering the embark column, engineering the age column. All right, not columns, column. Take a quick step again. All right, so what we first need to do is we need to handle the nulls appropriately. So, and I already, this is going to be very similar to how we handled the one hot encoding. It's a little bit different though. So I mentioned that we are going to fill the nulls with the median age, and so that what we call that is imputation of value. So we are imputing the age value here based off of the median age of the other thing. So scikit-learn in this case has the best, in my opinion, the best imputer that I know of. So we'll do scikit imputer. So it's just this simple imputer, and you can see like this is what we're going to be doing here. So you have different strategies. Default is mean. You could do mean, median, and well, I don't know why they call it most frequent, but it is mode. I guess mode can be confusing sometimes. So again, this is going to be very similar to one-hot encoding. I don't know if I have, again, this is a newer computer, so I don't even know if I have one-hot encode, or scikit-learn, I should say, installed on my machine. So pip install scikit-learn. Okay, so if it says requirement already satisfied here, then it's already been satisfied, or it's already been installed. In case you are curious on what is installed on your local workstation or what is installed as part of your virtual environment, and we're not covering virtual environments today, but maybe in the future we will. If you just do a pip list, that is going to show everything that you have installed from the as far as your library. So you can see where's scikit-learn? Scikit-learn, a little bit higher. It's this alphabetical order. Okay. 0.424.2. That is an old version of scikit-learn, right? I think. There's a way to verify that. So the easiest, well, maybe that's not. Maybe I'm thinking pandas, because I know one of these went to 1.0 fairly recently. So I just like to go in PyPy directly. PyPy pandas. And okay, so I was right about pandas. So pandas, you can see is 1.3.2. You can see the release history. So when did 1.0 come out? 1.0 came out in January 30th of last year, and so you can see it was quite the jump. It went from 0.25 to 1.0. So I started my machine learning engineer role right at this time. So whenever I was doing my studies, I was doing, back in 2019, I was doing a lot of this work with 0.2.4, and then it jumped over to the higher versions. So yeah, that's why I was a little bit thrown off by scikit-learn, because I thought, well, didn't it go to 1.0? And I don't think it did. So there's a way to check that real quick. Scikit-learn in here in PyPy. Okay, so it looks like 0.24.2 is actually indeed the latest. So again, if you want to look at the release history, you can see it all here. So it looks like 24.2 came out a couple months ago. Cool. All right, so that is good to go. All right, in order to import this thing, we are going to do from, again, I like to do things at the top here, from sklearn.impute import simple imputer, right? Right. Okay. So you'll notice that sometimes with these packages, they sometimes are organized in such a way that you kind of have to do like 2 levels to get down to something. Because if I were to just do an import of sklearn, I can do that. I can do an import sklearn, but if I wanted to actually instantiate the simple imputer, then I would have to type out this full thing. I would have to type out my imputer equals sklearn.impute.simpleimputer. The way I've imported it here within my notebook, then as such, then I can just reference it as simple imputer directly. All right, so let's instantiate this object. Instantiating the imputer age imputer object. So I'm going to call this age imputer equals simple imputer, and then got to remember our options here. So missing value, strategy. I think I'm only concerned with strategy. So strategy equals, and I mentioned we're going to select median here. Strategy equals median. There we go. All right, so let's actually fit the age, or well, fit slash transform. We're going to do a fit transform. Fit slash transform the age column into or with the imputer object. Imputer object. All right, there we go. All right, so let's do a imputed age equals age imputer dot fit transform And then we're going to do x.age. All right, I think I did this correctly. Let's check. Uh-oh, what did I do wrong? You reshape your data using a -1 if your data has a single feature, it contains a single sample. Ooh, did I do something wrong here? Was it fit transform? Again, this is not my wheelhouse, so I don't have these things memorized off the top of my head. So I got to come back in here to do that checkout to see what I maybe have done wrong. So you could see that I'm supposed to pass in the x values and target value. What is target values? I don't remember that. Haven't I done this before? I thought I'd done this before. Okay, so all right, so oh, I know what it is. It's because there's a oh wait, no, never mind. I was going to say because there's a bunch of nans, but that's exactly what we wanted, right? We wanted the nans. So we expected a 2D array, got a 1D array instead. So it's just showing us the 1D array. That's not what I want. I don't remember what I. All right, so n samples, n features. I wonder if there's an example of how they did it. So again, they sometimes have examples of the imputers. So scikit-learn is pretty good. Well, I'm actually going to do a different approach. How to use scikit-learn imputer, or simpler imputer, I should say, simple imputer. Because usually people write blog posts like I do, kind of supporting these things, and then it'll show you how to use this. Or you can use one of these websites. So I'm just going to select this Stack Exchange website here, which this is not Stack Overflow, but this looks almost exactly like Stack Overflow. And for those of you familiar with Stack Overflow, you might even think, hey, isn't that Stack Overflow? No, it is not. All right, so missing values, np.nan strategy. All right, so imputer equals simple imputer np.nan. All right, fit. All right, so fit transform. All right, so your error is due to using fit transform on a NumPy array. Here's how I use it on a data frame. All right, so he is instantiating the imputer with the missing values equals nan, strategy equals median, axis equals 0. Okay, so let's see if I change some of this stuff up, if it'll correct it appropriately. So missing values equals nan. And then strategy equals median. And then what else did it show here? Axis equals 0. And I think that's correct. Well, let's leave off the axis equals 0 for now. Or maybe it does need it. Axis equals 0. 0. What do you mean? Thing? I wish I would have kept the other page open now. All right, so scikit-learn, simple imputer. So part of the struggle I'm having right now is I don't like to leave dead air, so I'm trying to talk the entire time, and I am not good at typing, thinking, and talking all at the same time. So I may stop the stream just so like we can come back next time and see like what am I doing wrong. So missing values equals default is npi.net. Well, that is by default, that is correct. So that I don't need to put this in here if I already have a default. Okay. All right. So let me come back in here again. All right. So fill value with default is none. Verbose copy add indicator. The add indicator is actually pretty useful in some cases. All right. Is it just that I've not? Huh. All right, so let me try a different. Sometimes I look at these things. I try to use one that is how to handle missing data with. Sorry, I'm trying to think and talk at the same time. I always look for posts that are most recent. So that one that I just looked at is 2019, and it may be correct, and I just am not reading it correctly. All right, so imputer, simple imputer. All right, so missing values is fine. All right, so output, all right, so that has the output of the array there. All right, so imputer.fit the data. So that is just like an array. All right, so let's do simple, all right, scikit-learn simple imputer data frame. Okay, and let's see if it'll tell us how to use a simple imputer with a data frame. All right, here we go. Stack Overflow, help me out, guys. All right, so pda.data frame, imp.fit transform the whole data frame. So you are trying to impute a nan, a string, whereas you replaced a question with blah blah blah. All right, so replaced. Okay, so missing values equals nan. This one's not too helpful. All right, not for me at least. All right, so let me come back. Oh my gosh, come on. All right, there we go. Is there a way? All right, so imputing missing data using, so I'm hoping this will help me out. All right, I want to get this right before we stop the stream. And I don't know if we're going to be able to finish the age out, and I'll tell you what we want to do. Well, actually, no, we'll finish it out because I actually do know how to do the last thing. I'm just being dumb right now. Okay, so fit transformed values.reshape -1 1 0. Okay. All right, simple imputer for imputing missing numerical data. All right, so I don't know why it shows that. So okay, it looks like I might need to do a reshape on this. All right, so let's see if this will work. All right, so coming back down to here. Okay, so I don't need this because this was wrong. So just FYI, like when I first started learning this, scikit-learn did not have a simple imputer object. It was just imputer. So I wonder if that old 2019 post was referencing that instead of this newer one. And that may also be why I'm getting super confused on some of this. So, okay, so let's try to do a reshape. All right, I have an extra paren in here. Got a 1D array instead of 2D array. So let's take this part out. Reshape. Okay, so let's check it to see if that did this correctly. So imputed age. Okay, so we have this as, okay, I think this is all correct, but it's all in this weird form right here. So imputed age, I think there's a way to transform this back into a pandas data frame. So let's see if we can do like df imputed equals pd.dataframe. Data equals imputed age, and I just want to see what this does because this may or may not fix the issue, or putting it back into a pandas data frame. Okay, all right, this looks correct. Okay, so let's see, how do I put the column name back on it too? So pandas data frame, I think it's, maybe it was just columns. Columns equals, oh, wrong notebook. We don't need this notebook anymore, so we'll go ahead and close that out. Columns equals, and I don't remember if you have to have it in brackets or not. I'm just going to call it age imputed. Oops, not age impute, age imputed. Okay, that worked. All right, so there we go. So we did have to do a reshape. So what this was reshaping, what this was doing was, it was reshaping this into a different kind of array matrix that that this age imputer could work with. So that is good to keep in mind. That'll be interesting to see how this works moving forward when we actually export this thing. So let me add a comment here for organization's sake. All right, so creating, or I should say recreating the pandas, the age imputed feature as a pandas data frame. Okay, and of course, you might recall that we need to join this back into our data set, joining imputed column back in, or imputed age column. I'm trying to be extra clear here, just in case people just read this notebook and don't watch their live stream again. All right, so joining imputed age back into full X data set. So as you can recall, that is x dot equals pd dot concat. So this is concatenating them together. So we want our X data frame and the df impute there. In fact, let me make this a little imputed. I'm going to call this imputed age, just to make it extra clear. And I need to redo that. Imputed age. Axis equals 1. Equals 1. Okay, so let's do just look at our data there. So okay, so there's our age imputed column. Okay, so all right, so we do have one example here where it did impute the age appropriately. So you could see a null here. So it looks like the median age was about 28, and that seems about right. Okay, so let us delete the original. Getting rid of the original age column. All right, so again, that is x dot drop columns equals age in place equals true. Whoop, not in place. In place equals true. All right, and then again, I want to do a quick check. Okay, so this was step number one. So what I could do here is I could say, you know what, this age column is good. I'm not going to do anything more here. This is where I personally am going to take it a step further. And the reason I'm going to take it a step further is let's just think about the Titanic in general. So with the Titanic, you want to know who survived, who did not survive, and thinking like, you know, whenever you think about who got off the ship first, my thought is, you know, thinking back to, you know, what am I trying to say here? Basically, what I'm trying to say is I think that age and gender are probably the most influential factors. And the reason I say that is because I am willing to bet that with the Titanic, that women and children were let off the boat first. So in that sense, I do not think that this is the age is necessarily a good predictor value because it is just a float integer right now, just showing each of the individual ages. So what we're going to do is we're going to bin these into appropriate buckets. And what I mean by that is I'm going to take everybody from 0 to 8 years old, or let's say 0 to 11 years old, or 12 years old will be considered a child. 12 to 20-year-old will be considered or a 13 to 18-year-old will be considered a teenager. 18 to, let's say, age 30 would be young adult. 30 to 50 would be adult. And then 50 and above would be elder. So that's I think these are going to be more predictive for our model here. Again, that is up for dispute, but this is what we're going to do anyway. So in order to do that, first we need to create what our bin values are going to be. Establishing our bin values and names. So the bin values are going bin, or let's just call them age bin values. Okay, sorry, keep going back and forth. Bin values equals, all right, child, teen, young, adult, and elder. Okay, bin values. I don't know if I like that name, so let's just call them bin names. There we go. Bin names, and then the bin values. Okay, this is better. Bin values. So we need to start at because the way this function that we're going to be using works, we actually have to start at -1 if we wanted to get it to -1. And well, actually, let me just show you because I can't remember what it exactly requires. So I think it's called pandas.cut. Pandas cut. So this is going to bin things appropriately. So we need to pass in the data, the bins, and the labels. So the labels, that's what I wanted to call it. So bin labels, and all right. So it is expecting, all right, the bins, so by integer. So I'm going to say, and I think it's the upper end that it expects. So I think it's 0. So if I wanted to get like a bin between -1 and 12, or 0 and 12, or 13, then I need to do -1, 12. So I think let's do 12, 19, 30, up to 30 as a young adult, up to 50, we'll say 60, up to 60 is a regular adult, and then up to 100 is an elder. All right, so we did that, and so like I was mentioning there, to actually apply these to our values, we need to do, so applying age binning with pandas cut. All right, so in order to do that, all right, so I'm going to call this age bins equals pd dot cut. Okay, I think it's x age All right, I need to come back in here. All right, so bins and labels. All right, so the bins are going to equal, all right, bins equals bin values, and then bin labels, or labels equals bin labels. Labels equals bin labels, labels. Ugh. Of course I did it wrong. Key value missing. Oh, that's because I changed it. It's age imputed now. Okay, easy fix. Age imputed. All right, so let's check to see if that did that right. Look at that. All right, so we actually do need to take this one step further. And so as you can see, we do have we do have the appropriate values for each of these things. So actually, let me just show. I'm so happy that this one worked out the first time because I'm a little bit embarrassed about like how long it took me to figure out the imputation. So the fact that this worked all right is just great for me. So it just created one feature with our age bins here, and so it actually didn't create it as a pandas data frame. So let's change that real quick. Ages df equal, or I like to put df age. I like to put df first. Df standing for data frame. Df ages equals pd dot data frame. So data equals age bins, and then columns equals age bins. All right, so df ages. Oh, row. What do we do wrong? So age bins equals pd.cut. Well, what type is this age bins anyway? Age bins dot d type, because I thought it was just a numpy array, but maybe it's not. Categorical data type. Okay, so age bins. Okay. All right, so it's right. Okay, so PD got cut. All right, what is it? What is the output of this? Returns an out of a categorical series or ID array, and then the bins. All right, so pandas cut to data frame. All right, let's see what it has to tell us here. All right, how to use pandas cut. All right, so it is. All right, so what is this person doing? PD.cut, include lowest, see the difference. Okay. I don't know if I did something wrong here. So this is correct at least. So just let me show you real quick that this did indeed work. So although there are a lot of young adult ages imputed, age imputed, head. Okay, so you can see here, first person was 22 years old, young adult, 38, adult, 26, young adult, and then adults. So let's do a tail on this because I do see a teen in there. Tail. All right, so yep, 88, row 887 is indeed a teenager. Okay, so I did the pd.cut. So we need to get this back into our data frame, and then you can see, so this is just one feature that is string values, and so now we need to take one step further to do, again, the one-hot encoding. So we need to do, and we need to instantiate a different one-hot encoder. That should be quick as soon as I figure out how to get this back into the form of a data frame. All right, so age bins. All right, well, let me just try something out real quick. Well, pd.dataframe age bins. All right, so what did that do? Okay, so that did work. I wonder if I just did something wrong. Okay, so let's just do df age bins equals this, and then the column. And then was it just that I did the column names wrong? Columns equals age bins. All right. So df. Maybe I did do it right and I just didn't run something right. Sometimes I do that. That's the one nice thing and the one bad thing about doing. Okay, I did something wrong again. Let me just take this part off and see what happens. Okay, so I wonder if it's columns equals age bins. Okay. You know what? Just for simplicity's sake, I'm just not like I'm fine with it keeping it like that. And I need to change these into one hot encoded values anyway. Okay, so what I was saying with the Jupyter Notebook, the nice thing and the one bad thing about it is because you can obviously run cells out of order here. So you can see here, this was run. This first one here was run on the 60th time, and then you can see that I did some jumping back and forth in here. And so this can really throw people off if you don't do things in order. Like if you say, I want to build, this is how I built my model, but I run this cell, then this cell, then this cell, then this cell, then this cell. That's bad coding practices. So don't, and that can really throw things off, and that may have thrown me off here. So what I need to do here is we're going to create a new one hot encoding thing. So new, well, let's just copy this from up above and then change some stuff in here. Okay. Whoop. Well, actually, let me do a quick thing. I just want to see what the distribution of these bins are. So df age bins, age imputed dot value counts, counts. All right, I'm gonna again put a descriptor at the top here. So all right, viewing the distribution of age bins. Okay, so you can see that we have a lot of young adults, which should be about right since the median was about that. Several adults, not that many elders, a lot of kids, or a good amount of kids and a good amount of teens. All right, so okay, so what did I want to do here? So instantiating the age one, oh my gosh, one hot encoder object. All right, so I'm going to change this to age one hot encoder equals one hot use categorical names full missing. Handle missing as, ooh, I don't want to handle this one. I don't remember. I think we'll just call it other. Oof. Yeah, I don't remember what to do here. Or not remember what to do, or how to handle this appropriately. I'll just call it other, and we'll see how this works. All right, so let us fit this data. So fitting the age bins data frame to the what do you call it? Fitting the age bins data frame to the OHE object. And just to make perfectly clear what this is, since I don't want to confuse anybody with abbreviations, OHE. So all right, so let's call this, what did I call it above? I called this, oh, dummies, duh. All right, so age dummies equals age OHE encoder dot fit transform, and I transform as df age bins. Okay, so let's look at the age dummies. All right, so there we go. So we have, wait. We don't have any nulls here. Handle unknown. I wonder what handle unknown is going to do. Since we already handled the nulls. Okay, so there we go. So that, okay, so I'm starting to learn what handle missing versus handle unknown is a little bit. So we'll see how this works in the future. So you can see we do have our different things, and I am not happy that it did include the original name here. So, but that's fine. It doesn't really matter, like, because the feature name doesn't matter to when we create the algorithm itself. It's just looking for these numerical values. So we have done that. All right, so we are ready to join this back into our primary data set. So joining age dummies back into full X data set. So again, this is our easy one, pd.concat x age dummies axis equals 1. Okay, and then okay, so let's do a quick check. All right, so there is all those things, and then we can drop the original column. So getting rid of the original age, or actually age imputed, or actually age imputed column, as we no longer need that. So that is x.drop columns equals columns equals, oh my gosh, I'm blanking right now. Age imputed. My brain is going. We're going to stop the stream here shortly because we're actually coming down up to a wind down point. In place equals true. Okay. All right. Viewing the final engineered features. Oops. All right. So let's just do x.head. All right, so these are our engineered features now. So now we have things in the one hot encoded form. We have done so. I would want to also check viewing information about the X data frame. All right, so x.info. All right, just want to make sure. All right, so we have no nulls and everything is in numerical form. Some of it's in float, some of it's in integer value. And so we are basically done with this point. So within the next stream, we will cover actually like how we're going to use this data to actually train a predictive model. So this was, the thing that we did here is easily takes up the most amount of time, in my opinion, for actually like creating a predictive model, and that is feature engineering. So we've gone for a little over an hour and a half, and we did basically 2 features. We did age and embarked. Imagine a data scientist job of trying to do this for like 40 or 50 features, and this is why it's important to have stuff like what the industries are now coming out with called feature stores. And what a feature store is basically doing is it's saying, okay, I already engineered this feature one way. Instead of you, my other data scientist friend, going and doing the same thing, we create a feature store, and you can just go and grab these features as I already did them. That way you don't have to reinvent the wheel every single time. So that is the importance of a feature store. All right, so this is a good place to end it. I'm going to save this data set out, and I don't think I've showed you how to do the save out. So, all right, so saving cleaned data set to disk. So the way to do that is just doing the x.toCSV, and you have to give it the location of your path. So I'm going to put it back in my data folder. I'm going to call this cleaned train.csv, and I'm gonna put index equals false because I don't really care to save the index values. And then the same with, if I of course can't forget the y value, so y.toCSV data cleaned or y.csv. I guess we'll just call it y.csv. Why not? All right, then equals false. So what this is going to do is it is going to save these things, what we have already done within these respective data sets, out to CSV files. And just to verify that it indeed did do that. All right, so cd data, all right, ls, all right, so open, then dot, okay. All right, so you can see here's my clean train data set. And let's open this with text edit, just because text edit's pretty easy. So you can, all right, so you can see here all of our different columns. At the very top here, you can see that those are the column names, and then you see all the values. So you see no nulls in here. If you were to see a null in here, you would see this is what a null would look like. And I'm not, I don't want to edit that. Null is basically just like something that's literally not there, and you can see with the, it's like empty space between the commas there. Okay, so I don't want to edit that. All right, so that is it. Let me go ahead and push this up to my personal GitHub so you can all have it if you'd like. So git status, just to see what changed. So as you can see, what did change? I changed the feature engineering notebook. I added these new data sets. All right, git. I don't know what ds store is. Let me do something really quick. Git ignore. All right, so I'm going to add something to the bottom of this. I don't remember what dstore is. So what this get ignore does though is if you don't want if there's something that's part of your project that you don't want uploaded to GitHub or something like that, then you just add it to this get ignore file. So I'm going to add .ds store. What was that? Let me. Okay, so by default, the Mac does not show everything in here. So if you do a Command Shift period, it will show like the hidden files. And I don't know where dstore is coming in, but I'm going to remove it anyway. Was it just called dstore? Okay. Ooh. Okay, so let's do a get status again. Get status. Okay, now you can see that get store has been omitted. All right, so I modified the get ignore file, I modified the feature engineering notebook, and I am adding these new files. So I am going to do a get add all, and then I'm going to do a get commit m with the message of adding feature engineering notebook and data, get push origin main, and it should go to GitHub. All right, it's up in GitHub. And folks, that is it for today. So we went a lot longer than I thought we would today. So I apologize. You got to see me fumble through some stuff, and that is really like what a software developer's job is really on a daily basis. Is we fumble through things, we read documentation, we figure it out, we work through our issues. So I personally have a lot of fun doing this. I think this was a lot of fun. Not sure when I want to schedule the next live stream. So if you all enjoyed it, I'll probably do another one this weekend. Why not? It's a 3-day weekend. I don't want to keep you all waiting. And so with the next live stream, we will talk about like starting to actually preparing our data, or like actually starting to do some fitting of the data to a predictive model. And then yeah. So we'll go ahead and end it here. If you have been watching this whole time, thank you very much for sticking around the whole time. You all are great, and I will catch you in the next stream. See y'all later. Have a great weekend.